Google's latest RT-2 AI Overlord empowering the future of robotics. Google has unveiled RT-2, a groundbreaking AI model designed to facilitate natural conversations between humans and robots. This development marks a significant advancement in the field of human-robot interaction. RT-2 represents Google's continued efforts to enhance communication and collaboration between humans and machines. The AI model's capabilities extend beyond mere command-response interactions, aiming to establish more fluid and contextually rich conversations. By enabling robots to understand and respond to human speech patterns, annotations, and nuances, RT-2 could revolutionize various industries, including manufacturing, customer service, and healthcare. This announcement underlines Google's commitment to pushing the boundaries of artificial intelligence and its applications. As technology continues to evolve, RT-2's potential impact on automating tasks, improving user experiences, and fostering human-robot cooperation is both exciting and transformative. RT-2, or Robotics Transformer 2, stands as a cutting-edge vision-language-action, or VLA model. It blends vision, language, and action capabilities, enabling robots to comprehend both textual instructions and visual cues and translate them into meaningful actions. This fusion empowers RT-2 to bridge the gap between human communication and robotic execution, making it a pivotal advancement in the realm of AI-driven robotics. RT-2 is a groundbreaking innovation composed of two integral components: the Vision Language Model, or VLM, and the Vision Language Action Model, or VLA. The VLM forms the foundation, learning from an extensive array of online text and image data, akin to human learning from various sources. It grasps the essence of objects, their relationships, and contextual understanding, translating this knowledge into a form that the VLA can utilize. The VLA, on the other hand, is the bridge between comprehension and execution. It not only imbibes information from the VLM, but also incorporates robot-specific data like images, commands, and responses. This amalgamation empowers the VLA to generate actionable insights, converting its understanding into real-world robotic tasks. The synergy between VLM and VLA propels RT-2 into the forefront of AI and robotics, enabling a harmonious blend of linguistic input, visual recognition, and dynamic action. The Vision Language Action, or VLA model's proficiency emerges from its dual learning sources, online data and robot-specific insights. By assimilating vast online information, the VLA comprehends a wide spectrum of concepts. Additionally, it integrates robot-specific data, including images, human commands, and the robot's responses, refining its understanding and capability. Large language models have the potential to facilitate fluent text generation, emergent issue solving, as well as creative generation of prose and code. Vision language models, on the other hand, make it possible to perform open vocabulary visual identification and even have the ability to draw complicated conclusions about object-agent interactions in images. The most effective means by which robots can pick up new abilities need to be elucidated. It is quite improbable that the amount of data acquired from robots will be equivalent to the billions of tokens and photographs required to train the most advanced language and vision language models on the web. However, because these models reason about semantics, labels, and textual cues, it is difficult to easily adapt them to the actions that are performed by robots. On the other hand, robots need to be taught low-level activities, such as those involving the Cartesian end factor before they can perform them. Through the direct incorporation of vision language models that have been trained on internet-scale data into end-to-end robotic control, the research conducted by Google DeepMind intends to increase generalization and enable emergent semantic thinking. We plan to create a unified, all-encompassing training model with the assistance of web-based language and vision language data in order to teach robots how to link their observations to their actions. They promise integrating data from robot trajectories and large-scale visual question-answering exercises that are conducted via the internet in order to fine-tune state-of-the-art vision language models together. In contrast to the other approaches, they suggest a basic and general-purpose formula, which is as follows. Describe robotic actions as text tokens, and then directly include them into the model's training set in the same way that natural language tokens would be used. RT-2 is an instance of the Vision Language Action Models, or VLA, that are studied by researchers, and one of these models is RT-2. They were able to determine that RT-2 had acquired various emergent skills through internet-scale training, and that the technique led to performant robotic policies as a result of intensive testing, 6,000 evaluation trials. As a follow-up to its robotics transformer Model 1, Google DeepMind has introduced RT-2, a transformer-based model that can directly conduct robotic operations and was trained using web-sourced text and imagery. They make use of robot actions to represent a second language, which can then be turned into text tokens and taught in conjunction with large-scale vision language datasets that are available online. The process of inference involves turning text tokens into robot behaviors, which may subsequently be regulated using a feedback loop. This enables some of the generalization, semantic comprehension, and deductive reasoning capabilities of vision language models to be transferred to the process of learning robotic policies. The model has not lost the capability to use its physical skills in a manner that is compatible with the distribution discovered in the robot data. Nonetheless, it also learns to apply those talents in unexpected circumstances by reading images and language commands using the information that it has gleaned from the internet. Even though the robot data does not contain semantic clues such as exact numbers or icons, the model is nevertheless able to reuse the pick-and-place abilities it has acquired. Even though such relations were not provided in the robot demonstrations, the model was nevertheless able to select the appropriate object and place it in the appropriate area. In addition, the model is able to draw even more complicated semantic inferences if the command is combined with a chain of thought prompting. For example, the model is able to determine that a rock is the best choice for an improvised hammer, or that an energy drink is the greatest choice for someone who is fatigued. The most important contribution made by Google DeepMind is a family of models known as RT-2. These models were developed by fine-tuning enormous vision language models that were trained on web-scale data. Their purpose was to serve as generalizable and semantically aware robotic rules. Experiments investigate models that have as many as 55 billion parameters, which are learned from data that is freely available to the public and annotated with robotic motion orders. They demonstrate that RT-2 permits large increases in generalization across objects, scenes, and instructions across 6,000 robotic assessments, and reveals a range of emergent abilities that are a result of web-scale vision language pre-training. In addition, RT-2 demonstrates that it is able to generalize over objects, scenes, and instructions. Principal attributes: the powers of reasoning, symbol interpretation, and human identification that RT-2 possesses can be applied in a diverse selection of real-world contexts. The findings of RT-2 show that pre-training VLMs with robotic data can transform them into robust vision language action, or VLA models, that have the ability to directly control a robot. Constructing a general-purpose physical robot like RT-2 that is capable of thinking, problem-solving, and information interpretation in order to carry out a variety of activities in the real world is an exciting and potentially fruitful avenue to pursue. The ability of RT-2 to transmit information from verbal and visual training data to robot movements demonstrates the adaptability and efficiency with which it handles a variety of tasks. Restrictions or boundaries. RT-2 has a number of deficiencies, in spite of the fact that its generalization qualities are quite hopeful. Even though research suggests that introducing web-scale pre-training into VLMs can increase generalization across semantic and visual concepts, this does not confer any new capabilities on the robot in terms of its ability to perform motions. Even though the model can only exploit the physical abilities discovered in the robot data in innovative ways, it does learn to make greater use of its capabilities as it goes along. They explain this phenomenon by pointing to the necessity of having more diversity in the sample along the competency dimensions. The use of novel methods of data collection, such as films of humans, offers an attractive prospect for the conduct of future study on the acquisition of new abilities. To summarize, researchers at Google DeepMind showed that large VLA models could be run in real time, albeit at a significant computing cost. However, this was proved to be possible. The potential for real-time inference errors to become a serious bottleneck arises as these methods are put to circumstances that call for high-frequency control. Quantization and distillation techniques are interesting areas for future research, since they have the potential to allow such models to run more quickly or on less expensive hardware. This is connected to an additional limitation that already exists, which is that only a limited number of VLM models can be used to construct RT-2. Researchers from Google DeepMind outlined the steps involved in training vision language action, or VLA models, by combining pre-training with data from robotics and vision language models, VLMs. After that, they presented two variations of VLAs known as RT-2 PALME and RT-2 PLAIX, both of which were inspired by PALME and PALIX, respectively, to to generate robot actions, which are then tokenized as text. These models are fine-tuned with data on robotic trajectories to get the desired results. So that is it for this video. Subscribe if you want to watch more AI videos like this.